Hello everyone, my name is Satrio. I'm from Graduate Institute of Automation Technology. So for today's presentation, I would like to talk about deep learning application for Indonesian food detection. So what I want to talk in this presentation is the first is introduction, method, result, and the last is conclusion and future works. For the first, as you can see in this graph, for countries with the most obese people, including United States, China, India, etc. And for this graph, we can see that improper food consumption is very common for several health issues globally. And then, for diabetes has become a major threat in recent years. As you can see in another graph, for the data I got for Indonesian Ministry of Health, start from 2007 until 2018, overweight people and obese people, which is for diabetes people in Indonesia, has been increased. So, one of the most important thing in manage diabetes is to monitoring of food consumption and following an effective diet plan. And food logging, what I want to do in this application, can also help in this case to manage other chronic disease and achievement fitness goal manually. For the solution, writing down what we eat, it can be one solution. But for approach is tedious and non-effective and also non-efficient. But on the other side, the people have enjoyed taking photos of food and posting to social media. We can use this habit for our effective food logging. Many Indonesian dishes tend to be covered in flour, then deep fried to give their food a crispy interior and juicy interior. However, deep fried foods are often high in carbohydrate and fats, and also they have a lot of extra calories in for your meal. So, based on this problem, I choose Indonesian food to be my dataset in our food lodging application. Food lodging in this research is implement deep learning with a YOLO model to detect the food and report the cost and also send the calories of the food. YOLO Fitritini is used in this research, which is they only have less than 35 megabytes for the size of the application. For the method, as you can see in this algorithm, so basically we use Android application, and this is the main form for my Android application. I use Flutter with C++ programming. We call the application is Diamond, is for dietary assistant food detection. Basically, our application is taking the photos and then send to food recognition system, which is we implement YOLO V3D model, and we code using Python programming in Colab, and then we also have Indonesian food dataset, and then we also combine with calories info database. So for our food recognition system, we will send the similar food with the photo that user take for their phone or their camera, and send the name of the food and also the calories information of the food. So basically in my application, I use Python for coding my deep learning, and I use C++ to coding my Android application. And it's proper for Android, not for iPhone. Yeah, so because our target client is for Indonesia, and Indonesia most people using Android, so we choose Android application in this research. For the data set, we take a lot of images, more than 10,000 images I take from internet. So I use web crawling to download all of the dataset from the Google, and I use one by one because I have 51 class. For example, we have, this is the Indonesian food. Maybe you can see like fried rice, milk, fish, chicken, and something like that. And this is a kind of Indonesian food, and the total is more than 10,000. And I took it one by one. It will take a lot of times. And for the example of the food is we have like this name is koloke, is like Korean chicken in Taiwan, and we also have meatball, we also have satay, it's like I don't know in Taiwan. We also have tofu chicken, fish, and we have tempeh. And the most famous food in Indonesia, we have Indomie, is like fried noodle in Indonesia, the most famous food in Indonesia. This is just example of the few food that I want to detect. And also for annotation, I use label EMG application and Anaconda to run, and I save the annotation using YOLO format based on TXT file. As you can see in this picture, this is the display for label EMG, and then this is the result for the class that I already annotation. For example, this name is buburayam.gbg for the image and buburayam.txt for the annotation. So because I have more than 10,000 images, so I annotation this image is one by one, and it's take a lot of time, a lot of day I spent to take this annotation. And basically this is the model for YOLO and YOLO V3 Tiny. Yeah, basically in YOLO they only use bounding box and coffin disk for all scale. I mean they don't use only one scale, but in YOLO V3 Tiny it will be more smaller because they only use two scale. That's why they call his name is Tiny, and the version is we use is V3. Because I think right now YOLO V3 is still the best and still and most proper in our application. For YOLO Tiny architecture, yeah, basically they have yeah something like that, a lot of convolutional. And for comparison between YOLO V3 and YOLO V3 Tiny is in the FPS. We can see YOLO V3 is have 2.4 FPS and YOLO V3 is have more faster. They have 15.6 FPS. But the accuracy is YOLO V3 is better. But for FPS, YOLO V3 Tiny is better than YOLO V3. And yeah, this is the result. I stopped my training on more than 100,000 epoch, and I finished this around 200 hours. Yes, around more than 200 hours. And for accuracy map at 0.5 I got more than 65 because we have collab, so I need to stop and play and something like that. And for the result for total class is 51. For example, we have apel, pisang, kopi, donat, kentang goreng, jamur crispy, ayam bakar, sayur asam, badak extra. And for this result, it will show the average position, true positive, and false positive for each class. And this is the result in Python application. When I use image for Python application, they can detect like ayam bakar, ayam geprek, batagor, ayam laos, watermelon, ayam goreng, and etc. And they get the result of the application in Python application. And also for result on real mobile application, I also get some image like can we detect apple is apple, pisang is banana, kopi is coffee, this is fish, and jamur crispy, ayam goreng, bubur ayam, and nasi pecel. I don't know the English name for this food. So basically they got some good percentage for using Android application. And for proven our result, I also take some video. This is the result for mobile phone application for some Android phone application, as you can see in this video. Okay, as below, this is a nasi kuning. Nasi kuning is like yellow rice. Yes, in English is yellow rice. So we can detect the yellow rice. And also for this one, we can detect this nasi goreng. Nasi goreng is fried rice. Yes, it's fried rice in English. We also can detect it. And also the last is, for example, we have nasi pecel is 49%, and nasi pecel, I don't know, just rice with peanut sauce. Yeah, something like that. And also for the last, for the result, I have evaluated all class on Samsung A51. For the total 50 class, I can My model cannot detect only 5 class, so I think it's proper and it's still good and still can be published for the others. And for the last, for the conclusion, in mobile phone application, a few menus will show a higher level of accuracy compared with many menus. It is because the difference in hardware for each mobile phone, and it was need around 80 hours for each 20 menus dataset. So the total is around 200 hours. After long time process, we combine around 50 menus first to put 51 menus to put in the model with the maximum accuracy that we can be achieved. And there are some factors that we are considered, such as the limitation size of mobile application because we need a more lower application, and we use hardware we want to use hardware NVIDIA GPU, but it needs more configuration and additional hardware, so we use Collab and it's free. Collab has limited time for each day, so it lot of times to train this model. And also Android phone specification effect defection result, especially for the camera quality, and the information of the calories in this result will be used for the future works. And thank you for attention.